All right, here we are in, what is this, day 6. We're going to talk about Zener diodes in our semiconductors class today. We've already talked about standard or general purpose diodes, and what we said about them is that, number one, current only flows in one direction, and number two, there's a 0.7 volt charge, plus minus 0.7 volts, that diode takes out of whatever goes through it. And that is what we refer to as a general purpose diode. This is forward biased. I will leave the extra E out. Forward bias. And they're used to limit current flow to one direction. We also talked about the fact that a diode has a maximum reverse voltage that it could handle. And you remember when we talked about that? We talked about this door. And we talked about the idea that that door only opens one way, right? You can only go out that door. You can't really come in it because it doesn't swing inwards. But if I push hard enough, eventually I'm going to break down that door, right? But let's think about this. Depending on who made the door, who made the frame, different amounts of pressure are going to knock down different examples of the same door, because that's not how they were designed to operate. So some you might need a 300-pound whatever to knock it down. Another one you might need 400 pounds because it would just happen to be a denser piece of wood, or the guy doing the welding did a little bit of a better job. It's not designed to work that way, so there's no measurements made in that direction. Okay? The only measurement that's made is how easy it is for the door to open, not how easy is it to break it down. Okay? A Zener diode, on the other hand, works completely backwards from a regular diode. Okay? Zeners drink Red Bull because they have wings. And if you twist yourself around a little bit, you can probably envision that looking like a Z. When a Zener diode is forward biased, about 0.7 volts, forward bias, current flows in this direction, and roughly a 0.7 volt charge. So from the normal operation standpoint, a Zener and a regular diode can be used interchangeably for the most part. So if I have a regular diode, I could replace it with a Zener and it works similar. However, when we use a Zener backwards, plus minus, the Zener will conduct at its rated Zener voltage. So one thing that's different about a Zener diode is that a Zener diode, based on the type of diode and the 1N number that diode lives under, in other words, its part number, on the data sheet for that diode it will say that the Zener voltage VZ is equal to, say, 5.4 volts. So the Zener diode has another number. Associated with it. Remember, this is semiconductors. It's not linear with regards to the first two quarters. We're going to be talking about DC and AC from here until you go to the dark side, after which you will continue to talk about DC and AC. All right. Here's a 6-volt circuit with a resistor, and what voltage will be across the resistor? 6 volts. Here's the bigger picture. First thing we'll do is we'll put a diode in here. And if I put a diode in there, what does that diode do? Any idea what that diode does? What does a diode do?
Current flow in one direction.
If current is only flowing in one direction, what do we call that?
Forward bias?
No. In other words,
I'm still trying to try.
at the beginning of the diode, we have this,
Okay.
right? Diode only allows current to flow in one direction. So this becomes this. Current flows this way. Remember, this is alternating current, right?
Mm-hmm.
Well, it doesn't allow the current to flow backwards. It only allows the current to flow in one direction.
So you have the different colors.
Right? So what we have is we have AC on one side and we have DC on the other side. In addition to that, I'm going to install a capacitor right here. And every time this voltage goes high, it's going to charge the cap. The voltage is going to go away. The cap then being charged is going to discharge out through the resistor. And we're going to ultimately end up with a pretty flat waveform of DC going into this part of the circuit. The diode is limited flow to one direction, and the capacitor is smoothing that out. Remember, capacitors oppose a change in voltage. When this thing pumps up, it fills up the cap with electrons. The cap is charged. When the voltage goes away, the capacitor discharges. There's only one way it can discharge, through the resistor. It can't go that way because the diode's there. Okay, so we have an AC to DC, a very primitive but effective AC to DC converter that's taken our secondary output from our transformer and converted it into 6 volts DC. And ultimately, in my master plan, we're going to do the same thing with the 12 volts. And that's going to give me 12 volts DC. And everything is working great. I've got 12 volts to some part of my circuit. I've got my 6 volts that I need to run this load resistance. And everything is just hunky-frickin' dory, right? For how long? Uh-oh.
Wait a minute.
Uh-oh. Big trouble, Dawn. Big trouble just happened. Somebody went and dropped a paper clip in the circuit.
Or following safety protocol.
Something bad happened, and somehow a paper clip or a piece of metal got into this circuit somehow. And when that happens, am I going to have 6 volts at that load at that point?
Nope.
Nope. This is going to want to go where? Up to 12 volts? Because we have a paper clip that connected our 6 volt line to the 12 volt line. Not a good plan, right? You see how that happened?
Yeah, so what you're saying is that diode burn out and it's just nothing but a wire.
No, what I'm saying is we have 12 volts elsewhere in the circuit, and somehow, by mistake, that 12 volts got shorted out to this 6 volt line. Because somebody dropped a paper clip in the circuit somewhere, or something happened and shorted out 2 things in the circuit, so that what's supposed to be getting 6 volts is now connected up to 12 volts. That means that we're going to get 12 volts here and not 6. Which means that this now is going to get 12 volts instead of 6. And that, in many cases, would do what? Let the smoke out. Once you let the smoke out, the part's no good anymore. And the bad news is that this load resistor, even though we represent it as a squiggly line, is actually,
Some kind of equipment or something.
it's $4,000 to buy it. It's an expensive component. And we just fried it because some moron dropped a paper clip in the circuit somewhere else. But fortunately, We didn't, because we had the wherewithal to put in a Zener diode. Okay? What a Zener diode will do is it will begin to conduct in the backwards direction at its Zener voltage. We said that this one is not 5.4, it's 6.2 volts. That's what we wrote down here. Which means that when the pressure gets to 6.2 volts, this Zener diode will start to conduct. And it will take all of the extra energy and take it around the resistor. So it doesn't have to go through the resistor. The resistor, instead of being at 6 volts, is at 6.2 volts. Because the diode, the Zener diode, is acting like a pressure relief valve. You have those at home, right?
Mm-hmm.
Air compressor has a pressure relief valve. If the tank is rated for 100 pounds of pressure, you have a relief valve that when it gets to 90 pounds or something, it starts to let air out of the tank to preserve that limit. Okay, so I'm going to take a $1.79 Zener diode, and I'm going to use it to protect a $4,000 piece of equipment. Okay, so Zener diodes are used in reverse bias. In other words, we put them in backwards. But they are programmed to conduct backwards at a certain voltage. And that voltage is part of the description of the diode. So when you look up a diode based on a part number, 1N3350 or whatever, if it's a Zener diode, it will say what the Zener voltage is. They come in a wide variety, 6.2, 5.4, there's a number of different ones available. Not every voltage is available, but you generally don't need every voltage.
So that's when the floodgates open. It's when they hit 6.2.
As soon as it goes above 6.2, it will conduct what it needs to conduct in order to keep it at 6.2. Okay? You can't tell the difference from a Zener diode by looking at it. They all look the same. A Zener diode and a regular diode, they both look like this. But it will have in 1N7353 or whatever the number is. That's what you use to tell what kind of diode it is. You just have to go, most of the time, I just go to Google and type in 1N7353. It'll come up like on the right hand side and say, you know, made by Signetics or whoever, it's a such and such general purpose diode or a Zener diode. And you can get the data sheet and the information right there from the internet. Okay? So regular diodes are used forward bias. Zener diodes are used in reverse bias. And they function as a pressure relief valve, usually used for safety. Keep something from exploding or blowing up when it gets too much energy. Okay, questions? Dawn, you have any questions? All right, I'm going to stop the tape. Tape, yeah, right. There's a tape for you.